All right, welcome to this explainer. I am absolutely thrilled you're here with us today. We're diving deep into a strategic masterclass for conquering the CBSE Class 12 Computer Science Board exam. If you've been staring at your textbook, just kind of wondering how to translate all that code into maximum marks, you are in exactly the right place. We're going to break down the syllabus, decode the exact types of questions examiners love to ask, and build a solid roadmap to your highest possible score.
So here's the game plan. We've got the exam blueprint, mastering Python and logic, conquering file handling, data structures and stacks, scoring high with SQL, and finally, the practical exam breakdown. Let's jump right in.
Section 1. The Exam Blueprint.
Okay, so understanding the battlefield is literally step one if you want that top score. Looking at the 70-mark theory distribution, you've got computational thinking and programming sitting there like the heavyweight champion, worth a massive 40 marks. Database management brings in a solid 20, and computer networks rounds it out with 10. To totally dominate this exam, you absolutely have to conquer that 40-mark programming core. Now, unlike Class 11 where you were just building the basics, 45 marks on core programming fundamentals, Class 12 is a whole different beast. It shifts 40 marks onto advanced applications, things like file handling and data structures. They don't just want to see if you can write a simple loop anymore. They really want to know if you can actually use it to solve complex structural problems.
Section 2. Mastering Python and Logic.
This right here is the arena where you're going to secure the bulk of your points. Let's start with those foundational 1 and 2 mark questions. Let's actually test your instincts for a second with a real, highly expected 1 mark question straight from the exam patterns. What will be the output of the Python expression print, open parentheses, 2, double asterisk 3, double asterisk 2, close parentheses? Now, if you read this left to right and got 64, well, you just fell into a classic examiner trap.
The absolutely crucial thing here is your order of operations. In Python, exponentiation executes right to left. So for step 1, you have to evaluate 3 to the power of 2, which is 9. Then, in step 2, you take 2 to the power of 9, giving you the actual correct answer of 512. Seriously, do not drop easy points just because of basic syntax rules.
Another huge area for easy points, and honestly easy mistakes, is data types. Take a tuple, for example. It's a core Python data type for a collection of data, but the key takeaway is that it's immutable. You literally cannot change it once it's created. This is a total contrast to a dictionary, which relies on key value pairs and is mutable. Examiners absolutely love testing this specific jargon. If a question asks you to find the error and you see someone trying to reassign a value inside a tuple, you need to spot that immediately. Immutable means hands off.
Moving on to Section 3, Conquering File Handling. Now, this is a massive high-yield area where those predictable 4 and 5 mark questions just love to hang out. But before we write any code, we need to know exactly what we're handling. There is a fundamental difference between text files and CSV files. Both are human-readable, which is different from binary files that need that special pickle module. But while text files represent data in a standard ASCII format, CSV files take that ASCII data and organize it into a structured tabular format separated by delimiters, usually commas. They're basically spreadsheets in text form, and examiners are absolutely going to ask you to process them. So here's a classic expected 5-mark question for you. How do you write a Python function to read and count the total number of records in a file called apps.csv? You've got to be totally prepared to write this out from scratch on exam day.
Let's break the algorithm down step by step, because remember, partial credit is your best friend here. Step 1, always import the CSV module. Step 2, open apps.csv in R or read mode. Step 3, use csv.reader to read that data. And step 4, iterate with a simple loop to count the rows. If you can memorize that exact 4-step structure, you've essentially just locked in 5 marks.
Okay, Section 4, Data Structures and Stacks. This is a super vital piece of the programming puzzle. But the great news? You implement these using the Python lists you already know inside and out. There are 3 core stack operations. Push, which inserts an element at the top. Pop, which deletes an element from the top. And peep or peek, which just lets you inspect that top element. Because you can only access the very top, a stack strictly follows the last in, first out, or LIFO. But what happens if you try to delete an element from a stack that's already completely empty? Well, that brings us to a highly tested definition, stack underflow.
It's a critical condition in data structures, and examiners will definitely test your knowledge on this in the practical coding questions.
Which leads perfectly into this challenge. How exactly do you write a safe pop function for a stack named STK in Python to avoid crashing your entire program?
This is a brilliant illustration of how you secure full marks by anticipating the errors before they happen. Step 1 is your safeguard. Always check if the list is empty, so if stacky equals an empty list. Step 2, if it is empty, safely return none or print underflow. Step 3, only in your else block do you actually use the built-in stack.pop method. Checking that condition first proves to the grader that you actually understand the data structure, not just the basic Python commands.
Section 5. Scoring high with SQL. If Python is where you build the heavy logic, database management is your absolute best opportunity for quick, decisive points. Seriously, grouping SQL command types in your head like this is a massive game changer for exam time. You've got your DDL, data definition language, like create, alter, and drop, which defines the actual table structure. Then there's DML, data manipulation language, like insert, update, and delete, which manipulates the data inside. And of course your aggregates like max, min, AVG, sum, and count for performing calculations on groups. Categorize these properly and you won't get confused under pressure. And you absolutely have to anchor your SQL knowledge with this one, the primary key. It's a relational data model key that uniquely identifies each tuple or record within a database table. Being able to define this or spot it in a sample table is practically a guaranteed 1 or 2 mark question.
Finally, Section 6. The practical exam breakdown.
This is the final frontier. It's worth 30 marks, and it's where all that theory meets the real world. Here's the exact breakdown. Your lab test is the heaviest at 12 marks. Then you've got your project at 8 marks, your report file at 7, and the Viva Voce at 3. The biggest takeaway here? Your actual lab programming logic and the cleanliness of your code carry a massive amount of weight.
And speaking of that project, what is the ultimate goal here? Examiners want you to solve a real-world problem using Python file handling and SQL database connectivity. Think about writing a simple application for a local business that takes transactions and generates an invoice using SQL. Combining those two skills into a functional, real-world utility is exactly what they want to see, and it's how you nail those 8 points.
Wow, we have covered an incredible amount of ground today. You now have the blueprint, the highest yield topics, and the most expected questions. The roadmap to a top score is right there in front of you. So, my final question to you. Are you ready to open up that code editor, start practicing these exact concepts, and absolutely dominate this exam? I know you are. Thanks for hanging out with me on this explainer, and happy coding.